makes sense. Okay, on 23, we're solving an inequality. We want to just draw our lines down at each inequality symbol, and we're going to work our way out. So we need the a by itself, so we're going to add the 1 so that we're closer to having the a term by itself. Okay, so we now have 14 less than or equal to 7a, which is less than or equal to 28. Then to have a completely isolated, we would divide by the 7. So we divide each section by 7, and we get 2 is less than or equal to a, which is less than or equal to 4. Okay. Given the function 5x squared minus 9x minus 2, what is the value of f of 3.2? So we want to replace x squared, or x's, sorry, with 3.2, because they replaced x with 3.2. And that would be a type it in my calculator kind of problem. So let's do that. So back to here, we have 5 times 3.2 squared. I forget what the next part was. Minus 9 times 3.2. Minus 9 times 3.2. Minus 2. And we get 20.4. Okay, question 21. If 8r minus 3r and negative 2r and r are 2 points on the graph of a line and r is not equal to 0, what is the slope of the line? Okay, so slope, we know the slope of a line is found by subtracting the change, or finding the change in y's and finding the change in our x's. Okay. So if we look at our formula up here, this could be x1 and y1, and this one would be x2 and y2. So we do r minus negative 3r and negative 2r minus 8r. Now, because all of these are r's, we're combining like terms, so we can ignore the r and just use the coefficients to do our math. So in our calculators or in our heads, right, we can do 1 minus negative 3 over negative 2 minus 8, and we would find that to be negative 2/5. Okay. Now, because we were combining like terms, right, and we were just ignoring the r's because if we wanted to be able to put them in our calculator, we'll put the r's back in right now. Okay, so this would be negative 2r, and this would be 5r. Well, it would be, anyway, when it reduces down. All right, so now we notice that r divided by r is the same thing as 1, so really and truly our answer is negative 2/5. Solve the inequalities. We're just going to draw our lines down. Okay, you could use n-solver, but the problem with n-solver is you'd have to put an equal sign in, and then you lose the fact that when you divide by a negative, the sign can flip. So I don't recommend n-solver, but if you got nothing else, you could give it a shot. Okay, so we've got negative 3x is greater than or equal to 9. Then you divide by negative 3, and that dividing by a negative causes our inequality to become the opposite, so we actually have x is less than or equal to negative 3. Or we'll subtract the 7, and we have 4x is greater than 12. We divide by 4, and x is greater than 3. All right. Oh, I forgot to bubble here. This was for the previous one, so that's 20.4. Don't forget to bubble the decimal. Very important. All right, moving on. In a chemistry experiment, 2 chemicals are poured into a beaker to react. The temperature of the solution is taken every minute for 10 minutes, beginning at 105. The graph below shows the temperature of the solution from this experiment. What is a reasonable range for this function? Okay, so the range is measured along the y-axis. So we started at 10 and we go to 50. So from 10 to 50. Not 10 to 50, not 10 to 50, 10 to 50. Difference, y versus x. We measure y along the horizontal, so A is the best answer. Okay. Number 27, the graph is shown below. Which of the following equations are represented by the graph? I totally recommend utilizing your calculator at this point. Okay. Just going into graph and let's go ahead and do a dog B. Okay, so when we go into graph, the first equation was negative 3x minus 8. So that one we can just type in, negative 3x minus 8. We hit enter. We check it. It's going through at the right places. It's the right graph. Okay, so then we go back to our calculator. We can do another doc B. Hit graph. The next equation, okay, I can't put it in because of the plus 8, but if I were to remove the plus 8 to the other side, now I can totally type it in my calculator. So that's going to be negative 3, parenthesis, x minus 0, close parenthesis, and then it was minus 8. And I do my checking versus the picture and find it's the same one. So then I go to the third equation, hit tab, sorry, not tab, do a doc B, then do my graph. I can't put that one in here, but I can change my input, menu 3, 2, 1, 3, and that allows me to type it in, which was negative 3x plus y equals negative 8. Negative 3, enter, whoops. Okay, not enter, arrow. Negative 3, 1 for y, and negative 8. And when I hit enter, oh, it's in the completely wrong place, so it's not that one. So I do another doc B. I go to my graph. Okay. So this one worked, this one worked, this one didn't. I type in x minus 8 and x minus 3. So x minus, whoa, that's way too many x's. Okay, we'll try that again. Parentheses, x minus 8, close, open, x minus 3, enter. Totally not the same picture, so it's not that one either. So it's just going to be 1 and 2. Okay, on 26, the graph below shows the relationship between the number of tons of elephant food remaining in the zoo storage bin and the number of days since the food was last purchased. What is the rate of change? Okay, so let's look. How much did it change? We started off with 60, and by day 80, we were at 0 food. So we changed from 60 to 80, so we went down 60, and we went over a course of 80 days. So when we're decreasing, that's a negative rate of change, and when we simplify that, we get negative 3/4. Okay, graph the equation. I recommend using your calculator. Okay, we'll do a doc B to clear out what was in there. Go to graph. We have to change our input because it's in standard form. So menu 3, 2, 1, 3. We look at our equation again, and it was 3x plus 2y equals negative 12. 3, 2, negative 12. And we can pick up a point. It's going through negative 4, 0, and 1, 2, 3, 4, 5, negative 0, negative 6. So when we come over here, no, it's going here and through here, and we can draw it on there. Okay. All right. Question 29, graph the equation. Okay, same thing. We use our calculator. Okay, I'm just going to hit tab and go up and change my what I just had in there, which was to -2, x plus y equals 3. So that should be -2. That'll be +1. And that'll be 3. Oops, too far. 3. Was it 3? It was 3. Okay. And I hit enter. And so that's my line. Okay, but then underneath it says the slope of the line is multiplied by -1. Well, I don't currently have the slope on there, so here's what I'm going to do. I'm going to use my calculator to figure out what the slope is. Okay, so I can do that a couple of different ways. One way I can do it is to trace menu 5, 3, 1, enter. Okay, and I can then trace from a point. So it goes from -1, 1 to 0, 3. So if I go from -1, +1 to 3, I went up 2, and then I went over 1, so I know that my slope is 2. Okay. I have another way of doing it, but I'm going to have to show you that when in class if you want to learn a different way. So my current slope is 2, and it's going to get multiplied by -1, so that means my new slope is -2. Okay, and then my y-intercept decreased by 2 units. So my y-intercept was up here at 3, right? 1, 2, 3. So decreased by 2 means I'm going to go down 2, 1, 2. So I'm at +1. So my b value was at 3, but I decreased by 2, so now I'm at 1. So I put that together, and my equation in slope-intercept form would be y equals -2x plus 1. Okay, so on question 30, how does the graph of -3x plus y equals 2 compare to the graph of -4x plus y equals 2? All right, so we want to pull up our calculator, and we're going to graph the two on the calculator. Now, I'm already showing them graphed here, but if you don't recall, when you go to graph, hit tab. If it's not in this format for you, remember you can do menu, 3, 2, 1, and then 3, and that puts it in that format, and then you simply type in the numbers in front of the x and the y. Since there were no numbers in front of y each time, we put in a 1, okay, and I'll show you how the equations look. So -4x plus 1y equals 2, and the other equation was -3x plus y equals 2. So this is what they look like when they're graphed, and then what you want to do is make some comparisons. So some things that we can see quite easily is that the blue line intercepts the x-axis to the left of the red line. Okay, so we could say -3x plus y equals 2 has a smaller x-intercept than -4x plus y equals 2. We can see that both lines intersect each other right here at 0, 2. And then I noticed that the slope of the red line is steeper than the slope of the blue line. So I could say -4x plus y equals 2 is more steep than -3x plus y equals 2. Okay, those are some ways that you can compare two equations or two lines.